Hi everyone, in today's lesson we're going to talk about relations and functions. A relation is simply a set of ordered pairs or points in XY form. So here's a bunch of points put together in a set. That's a relation. A mapping is another form of showing a relation. So the way a mapping works is you're going to have two circles, one circle and another, and you're going to have arrows connecting numbers from one set to another. So basically, we're going to take everything in set A and we call that X, and everything in set B and we call that Y. So do you see how this arrow goes from 1 to 2? Basically, we're saying the X value of 1 pairs with a Y value of 2. So if we wanted to write this out as a relation, it would be the point 1, comma 2, comma, let's look at the next one, 3, comma 2. So that would be the next point. Then the next one would be 5, comma 7, and then 9, comma 8. So 5, comma 7, and then 9, comma 8. So basically, this mapping here is just another way of showing this relation. Okay, now let's talk about the definition of a function. A function is a relation where every x value is mapped to exactly one y value. So see this mapping here? I actually reproduced it down here so we could tell if it's a function or not. So remember I said everything in set A is considered x and everything in set y is considered b. So does every x value go to one place? So the 1 goes to 2, 3 goes to 2, 5 goes to 7, 9 goes to 8. They all only go to one spot, so yes, this is definitely a function. What would make it not a function? Just to show you, you don't have to write this down, but if 1 also went to 6, so you see how right here 1 is going to 2 and then 1 is going to 6? That can't happen because the definition of a function is that every x value goes to one specific place. It can't go to two different places. So that would make that not a function. Okay, let's look at the second one. We're going to go a little backwards here. Is this mapping a function? Does every x value go to one place? They can all go to the same place, but it's all about going to one specific spot. So 4 goes to C, that's okay. 3 goes to C, that's okay as well. Even though they're going to the same spot, that's okay because each of these x value goes one place. 2 also goes to C, still okay. And then does A go to one place? Or I'm sorry, does this 1 go to one place? No, 1 is going to A and 1 is going to B. So that is not a function. Okay, let's see if we could do these examples up here, if I give it to you in relation form. So I want you to focus on each x value first. So 1 goes to 2. Is there a 1 going anywhere else? No. Okay, so far so good. 3 goes to 2. Are there any other 3's going anywhere? No. Okay. 5 goes to 7. There aren't any other 5's. But look over here. 9 is going to 8, but 9 is also going to 10. So if this was in a mapping form, you would have the number 9 in the x, and you had to have 8 and 10 in the y, and 9 would be going to both places. So this is not a function. Okay, how about the second one? Does negative 3 go to 5? Okay, that's fine. Are there any other negative 3's going anywhere else? No. Okay, negative 4 goes to 7. Are there any other negative 4's? No. Okay, 9 goes to 0. Are there any other 9's going anywhere? No. 4 goes to 10. Are there any other 4's? No. 3 goes to 1. Are there any other 3's? No. So this is definitely a function. Okay, let's now talk about the definition of a one-to-one function. Simply, a one-to-one function is any function where every y value is mapped from exactly one x value. So the biggest thing that I can say here is that if it's not a function, it cannot be a one-to-one function. So right away, this one's not a one-to-one function, and this one's not a one-to-one function. They cannot be a one-to-one function if it's not already a function first. See how the word function is in the definition? Okay, so let's look at now these two possibilities that are could potentially be one-to-one functions. So we said a one-to-one function, if you want to read the definition one more time, is basically saying every y comes from one x value. So you see how this y value of a 2 over here came from a 1 and a 3? That's not good. That means it's not a one-to-one function. So we're going to put a no for this guy. So let's look at it as a relation. We said it was a function going this way. Now let's go backwards, starting with the y's. Is there any 1 anywhere else coming from any other place? No. Are there any other 10s coming from any other place? No more zeros, no more 7s, no more 5s, so we are good. This one is a one-to-one function. I know this can be a little bit challenging at first, so any questions that you might have, please jot down and we can go over this tomorrow. Now let's go to the easier part. Okay, the graph of any function must pass the vertical line test, and the graph of a one-to-one function must pass both the vertical line test and the horizontal line test. So the way that this test works is simply like this. You're going to draw a vertical line through your graph, and you're going to see how many times it actually hits that graph. So this vertical line that I drew hit once, so that means it's a function, because any vertical line that I draw will still only hit the function once. So here it hits, all the time it hits once, so we're good to go there. Now to see if it's a one-to-one function, we have to see if it passes the horizontal line test. So if I draw any horizontal line, how many times does it hit the graph? You should be saying it hits the graph twice, so this one is not a one-to-one function. Okay, let's look at the second example. Is this circle a function? Well, let's see. If I draw this vertical line, it hits 2 times. So definitely not a function. And like before, if it's not a function, it cannot be a one-to-one function. So that's out. How about the third one? Draw this line, hits twice, so not a function, can't be a one-to-one function. This graph up here in this corner, I believe was a picture. It was supposed to be a picture of a line like this. So does it pass the vertical line test? You draw a straight line, it goes through once. Good. Does it pass the horizontal line test? If I draw a line this way now, does it pass how many times? Once. Perfect. Okay, how about the next one? Draw a vertical line here, draw a vertical line here. Each one of these lines are still only hitting this function once, so definitely a one-to-one function. And definitely a function. Now let's test one-to-one. Draw a horizontal line, hits it once. Some of you may be thinking that it hits here, but it doesn't. I mean, this area is pretty close, but it's a gradual increase and decrease. So this one is definitely a one-to-one function as well. And let's look at that last one. So this one is hits once, function. Okay, how about a one-to-one function? Horizontal line test. Ooh, fails here and here. Hits twice. Not good. So no. Okay, now we can move on to the next page. Okay, so now we need to talk about something called domain and range. We talked about a relation already. A relation is simply a set of ordered pairs where the domain is the set of all x values and the range is the set of all y values. Sometimes we refer to the domain as the input and sometimes we refer to the range as the output, just for your reference. So here's example number 1. We've got ourselves a relation and I want you to tell me the domain and the range. Very simple. For the domain, we're just going to list all of the x values. So my domain is 1, 3, 5, and 9. I know there are 2 9s, but it's unnecessary to list them twice. All you have to do is list it once. Okay, now to state the range. So we're going to look at the y values. We've got a 2, we don't have to say it twice, so a 2, a 7, an 8, and a 10. So 2, 7, 8, and 10. Yes, it's that simple. Okay, how about example 2 and 3? What's the domain and what's the range? So my domain, remember, the first bubble is always x, the second bubble is always y. So my domain is going to be 1, 3, 5, and 9. 1, 3, 5, and 9. And my range is only the ones that are being hit. So 2, 7, and 8. Some of you may be wondering, well, why don't I include these numbers if they're already in this bubble? It kind of goes back to if you have a picture of a graph like this. If I'm making a parabola like that, right? Am I using any of these y values down here? No, this is like -2 or -3 or -4, whatever they are. Those y values aren't being used to make this graph, so those could be those extra pieces there. Okay, why don't you see if you could try example number 3. Pause the video and then check your answer. Okay, for your domain, you should have gotten 1, 2, 3, and 4. And for your range, you should have gotten 3, 5, 7, and 9. Okay, let's move on to the next page. Okay, now here is the bulk of the video. This is the most important part, is finding the domain and range from a graph. So remember we said domain is the set of all x values, and range is the set of all y values. So I want you to think of domain. Let's write this down. I want you to think of domain as how wide is this graph? And I want you to think range as how tall is this graph? Okay, so how wide, how tall? Okay, so let's look at a few examples. I think the best example to do first would be example number 6. So as far as domain goes, we're talking how wide is it. So we can clearly see that this graph is as wide as from here to here. So what are those x values and how wide it is? They start at 2 and end at 6. So your domain ranges from 2 to 6. So this is something called interval notation. It's very simple. You do 2, 6 with brackets around it. These brackets pretty much just tell you that I'm going all numbers from 2 to 6, including 2 and including 6. So that's it, 2 to 6. Now the range, we said, was how tall this thing is. Well, it's as short as 1, and it's as tall as 5. So 1 is the shortest, 5 is the tallest. So again, the range goes from 1 to 5, and you just put brackets around them, just like that. Okay, now let's look at number 7. I think this is the good order to go in. Domain is how wide it is. Now, do you notice how this graph here doesn't go past the 0 on the x? So it really starts from here and kind of goes on forever this way. Starts here and goes on forever this way. Now these should have arrows at the end, kind of like going like this. This is what it should really look like. So it looks like the graph is going to, if we're talking how wide it is, this graph will appear from 0 on. So we would write that as bracket around the 0, comma. Now, when I said 0 on, I meant from 0 to infinity, because infinity just never ends. So you put the infinity symbol, but infinity always gets a parenthesis. And the reason why it always gets a parenthesis, because it can never equal it. We use brackets when it could equal that number. You can never touch infinity because it's always one more. So if you want to write down something, you could write infinity always gets parentheses, never brackets. Okay? Alright, so now let's talk about range. So the range of this graph is now, how tall is it? Well, it looks like it's going down forever, and it looks like it's going up forever. So my range is from positive infinity to negative infinity, or in other words, all real numbers. That's a symbol for all real numbers. And we could have also written it as negative infinity to positive infinity. So those are the same things. Both this one and this one mean the same thing. So all real numbers or negative infinity to infinity. Okay, now we can look at these examples, number 4 and number 5. So for number 4, I want to do the range first. How tall is this thing? Well, it looks like it's stopping here. This is how tall it is. And it's going down forever. So the range is from negative infinity to 0 with a bracket. Now, some of you may be thinking, why aren't we going 0 down? And the reason is when we write this, which is called an interval, we always write the smaller number first, comma, the larger number. And in this case, your larger number is 0 and your smaller number is negative infinity. Okay, now let's talk about the domain. In this case, the domain may be harder to see, but it is going down forever. But while it's going down, isn't it going to the right as well? It's going down and to the right. Here is going down and to the left. So it's going right forever while it's going down, and it's going left forever as it's going down. So in this case, your domain is simply negative infinity to infinity. It goes on forever. Okay, why don't you see if you can do the last one, number 5, and hit resume when you're done for the answer. Okay, here it is. Alright, if you have any questions on any of this stuff, please write it down and bring it into class tomorrow. Alright, have a good night.